Hello students, I have a question here to solve a request from a student, that is sine to the power 6 theta plus cos to the power 6 theta is equal to 1 minus 3 sine square theta cos square theta is what we are supposed to prove as. So first convert this to the power 6 as sine square to the power 3 plus cos square to the power 3. Why? Because we can get a expansion of sine square theta to the power 3 and cos square theta to the power 3 as a cube plus b cube form. So I have written a identity here what we can use for. So if at all I follow the identity, sine square bracket raised to cube plus cos square bracket raised to cube is equal to, what will I get? First the sum of the bases what we have here, sine square theta plus cos square theta in the first bracket. In the second bracket, first term square, that will be sine to the power 4 theta plus cos to the power 4 theta, and the middle term I have written it at the end as minus sine square theta cos square theta. Now this bracket has already become 1. Why? Because sine square theta plus cos square theta is 1. Now here if we look into the second bracket elements, I am converting this sine to the power 4 theta as sine square square and cos square square. Now I am trying to make this as a perfect square by introducing plus 2 sine square theta cos square theta. But to compensate means if I add 2, I will have to subtract 3 so that it becomes minus sine square theta cos square theta again. That is a manipulation. So here sine square theta square plus cos square theta square plus 2 sine square theta cos square theta will give you a perfect square, which is sine square theta plus cos square theta bracket raised to square, and minus 3 sine square theta cos square theta will remain as it is. But as you know, sine square theta plus cos square theta is 1 square is 1 again, minus 3 sine square theta cos square theta, which is RHS. Hope you have understood. If you have any queries, please let me know again.